When we think about AI, we usually picture things like self-driving cars or chatbots. But today, we're going to look at how it's completely shaking up one of the most fundamental industrial processes on the planet. And believe it or not, creating some really fascinating new challenges along the way. So, really think about that for a second. How do you make steel strong enough for something like a jet engine? I mean, these parts are under insane stress. They have to be unbelievably hard, but also not brittle. They can't just shatter. The secret, it turns out, is all about heating and cooling the steel with just mind-boggling precision. But the real question is, how do you get that perfection every single time for millions of parts? Well, that's exactly what we're going to unpack. All right, let's get into it. This whole idea of making metal stronger, well, it's not new, not at all. It's an ancient craft that has turned into some seriously high-tech science. Way back when, you had blacksmiths, right? They were true artists, skillfully heating and cooling a sword to get that perfect hard edge with a flexible spine. But then the Industrial Revolution happened, and art just wasn't going to cut it anymore. We needed to make things consistently and on a massive scale. Fast forward to the 70s, and we get these early computers, PLCs, that start bringing in more control. And that leads us straight to today, where the whole process is, well, it's almost unrecognizable. It's fully automated, packed with sensors, and it's right on the edge of its next huge leap forward. So the technology that really kicked off this whole automation revolution, it's something called induction hardening. And trust me, it was a total game changer. So what exactly is it? Okay, the best way to think about it is like a super powerful, hyper-focused microwave, but for metal. Instead of chucking a whole part into a giant furnace for hours, you use an electromagnetic coil to heat up a very specific spot on the surface. And it does it in seconds. Then you immediately cool it down. That's called quenching. And the result? It's genius. You get this incredibly hard, wear-resistant outer layer, like armor, while the inside, the core, stays tougher and more flexible. It can take a hit without shattering. And when you compare this to the old way of doing things, it's night and day. I mean, traditional furnaces, they took hours, and they heated the entire part, wasting a ton of energy. Induction hardening, it takes seconds. It only heats the little bit of surface that actually needs it. And it's so clean and precise, you can just slot it right into the main production line. So you go from hours to seconds, from a whole separate building to just another station on the line. That's not just an improvement, that's a revolution in efficiency. And here's how it all works, step by step, in a modern factory. A part zips in on a conveyor. Boom. Fiber optic sensors lock onto its exact position. Then a roller system spins it through the induction coil for a perfect, even heat. Immediately after, it's quenched, cooled down super fast. Then there's a quick tempering step, which is just another little heat blast to relieve stress in the metal. And just like that, the finished part moves on to the next stage. The whole thing happens without a single person touching it. This is pure, beautiful automation in action. But here's the thing. Automation is really just about following a script, right? A pre-programmed set of instructions. So what happens when you give that system a brain? Well, that is the giant leap we're taking now, from simple automation to true autonomy, and it's all powered by AI. So now we're layering AI and machine learning right on top of these incredibly precise automated systems. The AI is constantly watching, analyzing just massive floods of data from all the sensors in real time. It's looking for tiny patterns that no human could ever hope to spot, and it's using them to optimize the process as it's happening. The key word here is adapting. It's not just executing a plan anymore, it's thinking. And what can this new brain actually do? Well, it's pretty incredible. It's not just about making the process run a little smoother, it's about making it genuinely smarter. It can actually predict when a part is about to fail a quality check, and then tweak the settings to prevent it from ever happening. It can see that a machine needs maintenance before it breaks down, saving a huge amount of downtime. And it hands engineers all this incredible data so they can make the whole operation better. And the results? They are absolutely staggering. Get this, one study created a hybrid model, one that mixed the power of AI with the basic laws of physics. And the result? It cut the number of prediction mistakes by 92% compared to an AI model flying solo. 92%. That's just a ridiculous leap in precision. That's the power we're talking about unlocking here. Okay, so this all sounds amazing, right? A nearly perfect process. But there's a catch. This incredible, almost unbelievable level of precision, it brings a hidden risk. a really subtle but really important problem that almost nobody saw coming. And this is what we call the paradox of perfect control. Here's the best way to picture it. Think of regular automation as a world-class orchestra. They have sheet music, and they play it perfectly, every single time. Now, AI is like adding a brilliant conductor who can listen and make small adjustments on the fly to make it even better. But what if the conductor misreads the music? What if they think a C sharp is a C natural? Well, the entire orchestra, with all its perfect skill, is going to play that wrong note together with beautiful, unified precision, and it's the exact same thing here. If you build an AI model on a flawed assumption, it will execute that flawed plan perfectly, churning out bad parts with terrifying consistency. And this quote from the research really hits the nail on the head. It basically says that a lot of current AI models are built with a blind spot. They're taught to assume that every single part coming down the line is geometrically perfect and identical. But we all know that's not the real world, right? In reality, there are always tiny, tiny variations. And that's just one tiny example of a bad assumption. The AI might also assume the chemical makeup of the steel is always exactly the same, or that a big, clunky part cools down perfectly evenly across its entire surface. Or it might not account for the fact that the machine itself is slowly wearing down over time. And if any of those wrong ideas are baked into the AI's brain, it's going to perfectly and precisely run the right process for the wrong situation. It'll do it again and again and again, turning a tiny little error into a gigantic quality control nightmare. So, does this mean AI is the bad guy here? No, not at all. The answer isn't to throw out this incredible technology. The answer is to make it smarter. We need to give it a better, more realistic understanding of the world by combining its power with actual human expertise. And that's where these hybrid systems come in. They are just so much more robust and reliable. What they do is they blend the amazing pattern spotting ability of AI with the cold, hard, unbreakable laws of metallurgy and physics. It really is the best of both worlds. You get a system that can learn from tons of data, but it's got guardrails. It's physically prevented from coming up with solutions that are just impossible or make no logical sense. So what does this actually look like? Well, for one, we're seeing something called physics-informed neural networks. It's a fancy name, but it's a simple idea. It's AI that has to obey the laws of physics. It can't just make stuff up. Then there are these hybrid models we talked about. And my favorite is a new idea called machine teaching. Instead of the AI trying to learn from scratch by just looking at data, a human expert with decades of experience can literally teach the AI their intuition, their gut feelings, their know-how. It's not about man versus machine. It's about creating a real partnership. And all this leaves us with a really fascinating question to think about. We always imagine the future factory as this empty place, completely run by robots. But maybe that's not the goal. Maybe the truly intelligent future isn't about replacing people, but about amplifying their expertise. A future where our deepest knowledge and our intuition are used to guide these incredibly smart machines, so that together we can achieve a level of perfection we could never have even imagined before.